It's giving me a bit of an attitude, but I think I've straightened out the attitude, and I think Sarah E., I think the laptop is now fully functional. So if I could call your attention back in, Alexandria, if we could put away the awesome book. Let's get going on this, because these quiz grades were not very good. And that's kind of to be expected after the vacation, but it's also the case that this material is material that kids struggle a little bit with. I think primarily because you've never really seen anything like it before. So let's go through all 4 of these questions, and hopefully you'll get a little bit of a better feel. I strongly recommend, before you take tomorrow's quiz, that you go back over this quiz. Yes?
There's something in my contact. Can I go to the bathroom, please?
Sure. Okay.
Did you take this door?
Are we ready?
Yes.
Okay. So these questions talk about sequences and ways to define sequences and so on. So the first question says, which recursively defined function has a first term equal to 10 and a common difference of 4? Now, if I was to write that out, this is how I write it out. The first term is 10, and the next one goes up by 4. So 10, 14, 18, 22, 26, 30, and so on. Now, one way to do this is to look at the choices and see which of the choices accurately, if you follow the function rule, get you from number to number to number. Now, choices 2 and 4 are utterly ridiculous, because in both cases they say that the function of 1, the output from 1, is 4. And it says here the first term is 10, so that can't be. Now we take a look at the rule. The correct way to read this is f of x is the new term, and f of x minus 1 is the previous term. We've talked about this many, many times this year. So the new term is the previous term plus 4. That will give you a common difference of 4. Let's try to follow the other rule and see if it makes sense. It says to multiply by 4. If I do 4 times 10, would I get 14? No. So therefore, choice 3 cannot possibly be for question number 1, okay? On the other hand, when this says to add 4 to go from term to term to term, clearly that's a common difference of 4. Any questions? Okay. Next up, this is an area where I just need to be a better teacher, because I don't do it this way. This is a little more structured than the way that my brain thinks, and I haven't done it this way very much with you so far, but I was tutoring a kid on this material just before the break, and their teacher had them draw this box out. And it's not my instinct to draw that box out, but it might help you. So I want to make sure I go over this little structure here. And all we're trying to do, God bless, all we're trying to do is be a little more methodical and keep track of what's going on. So it says f of 0 is 2. That means if I put in a 0, I get a 2, or my 0th term, if you will. And then, again, the new term, the function of n plus 1, is negative 2 times the previous term. N plus 1 and n, in light of sequences, in that context, God bless, must be thought of as new and previous. So in this case, this says to take the previous term, multiply it by negative 2, and add 3. So the previous term is 2, so I plug in a 2. Negative 2 times 2 is negative 4, plus 3 is negative 1. Now the new term, which is the second term, is negative 2 times the previous term. The previous term was negative 1. So negative 2 times negative 1 is 2, plus 3 is 5. So the answer is 5. Okay? One more time. The new term is negative 2 times the previous term. This last column is the previous term. This middle column is for computation. Okay? So this does not mean negative 2 times 2. This is not saying the input is 2. This is saying negative 2 times the previous term. So I have to look at the previous term's value, which in this case is negative 1. So negative 2 times negative 1 is 2, plus 3 is 5. So the correct answer is choice 3. Okay? Yes?
How do you know when you just plug in the 2 without having to
Do you see how it says if a sequence? So when it says sequence, that means get into the previous and new frame of mind.
Okay.
All right? Now let's go to number 3. This means if f of 1 is 3, means the first term in this sequence is 3. First term is 3. Then it's negative 2 times the previous term plus 1. So if I do negative 2 times that 3 plus 1, I get negative 5. But I got to go all the way up to the 5th term here. So negative 2 times this previous term, which was negative 5, becomes positive 10 plus 1 is 11. Then I got to do it again to get the 4th term. Negative 2 times 11 is negative 22 plus 1 is negative 21. Then I plug that in to get the 5th term because this is the 4th term. The 4th term is not 4. The 4th term is negative 21. I should have even written this out. This is your sequence. 3, negative 5, 11, negative 21. Then I plug that in. Negative 2 times negative 21 is 42, plus 1 is 43. So it's choice 4. Okay? And the last one is the kind of question that if you're not rock solid on what a rational number is versus an irrational number, you'll get it wrong. But it is a very simple question. For which value is it rational? Remember, any square root that you can figure out is a rational number. If you can't figure it out, it's irrational. Anybody here know the square root of 3 off the top of their head? No, can't figure it out. Let's go down to this. Square root of 6, square root of 10, square root of 2. Square root of 25 works, but square root of 2 doesn't. So this is going to be irrational. But over here, what's the square root of 4? 2. What's the square root of 9? 3. So this is really saying, what is the sum, p plus w, of a half and a third? That works out to be 5, 6. That's a perfectly rational number. So again, the key to determining rational versus irrational, in a rational number, you can find the square root. It is a perfect root. Okay? Any questions about that? Yes?
Can you go back up to number 3? Do you start, so you start with you plug in, wait, why did you plug in a 3 for the?
Because it says the first term is 3.
Oh,
So I plugged in a 3. And then based on that first term and the rule, which is here, I can generate the sequence.
okay.
All right?
That makes sense now.
Okay? Listen, it's really important to understand. You could hear the little light bulbs going off a second ago, and this is a good thing. But I'm not so sure those light bulbs will be crystal clear come tomorrow. So I think it's extremely important that tonight, before you begin your homework, that you take a few minutes to look over this quiz and redo these questions. And then, if necessary, watch this video for a couple of minutes at the beginning. And I think it'll help really cement those ideas in your mind. Remember what we said at the beginning of class. We said that at this point we want to begin to surgically identify the things that are giving us a hard time. And for many of you, this is a topic that's giving a very difficult time. Imagine if you take the 4 topics that are giving you the most difficulty right now and change them into topics that you've mastered, and then you take your Regents exam. You probably just went up 12 to 14 points based on those topics, or 10 to 12 points. So it's worth doing. It's painful at times, it's not easy, but that's what successful people do. Successful people know that the sacrifice is worth the reward, and they make that happen. Okay, so today's lesson is really, it's a very good lesson for the day after a vacation. All we're going to do is just introduce some different forms of data, and then starting tomorrow, we're going to analyze each of those individual forms. It says here, students conducting an experiment as time passes, number of cells in the experiment decreases. How many cells will there be after 16 minutes? As I take a look at this, there's a common ratio here, right? Not a common, I don't see a common difference. So Anthony, what you got?
Well, because I got this much, talking about cells, I got 638.
Well, let's very quickly see. I really don't know if it's right or wrong, but let's realize that this is an exponential regression, right? So everybody get your calculator out. What's that?
I disagree.
Is it not exponential?
No, it's exponential.
Oh, you have a different answer. Well, we're going to use the calculator to get the answer for us. Ready? Everybody go, everybody go to your calculator. List 1, list 2. Did anybody do it this way?
No.
I don't know, I forgot how to do it.
Okay. Input this data for list 1. Input this data for list 2.
Wait, I already found out what the equation is.
Good. What's that? Again, list 1, you go to stat edit, L1, 0 through 6, L2, these numbers. stat, it's right at the top, you're already there, just hit stat, enter. Okay? And just put that data in there. If you want, you can just put the first three of them, it doesn't make a difference, you got plenty of data here.
Alright.
Now, once that's in, go to stat calc and scroll down until you see exponential regression, EXPREG. And hit enter. Can someone tell me what they get?
5 million times 0.55 to the x power.
Y equals 5 million times 0.55 to the x. Now, it wants the 16th minute, so now just change x to 16. So do 5 million times 0.55 to the 16th. And what do we get?
350.
350.56, and this is a number of cells, so that means there's only 350 cells there.
350. I must have done a different equation, like I did x plus 1.
No, you had the
Yeah,
equation,
that's
right?
it.
You were just going to the power. It
Yeah,
was,
that,
extra
yeah, that's
50.
right. Yeah, that's right. That's
Okay, all right, so anyway, that's the power of the calculator. If it wasn't for that, it would be a very difficult question. All right, so the first thing I want to do is introduce you to a dot plot.
Oh, I like
This has a very simple name because it is made up of a bunch of dots. The
Isn't
big
it
thing,
nuts?
the big thing for you to understand here is this. Look, this goes from 0 to 10, so it's 2, 4, 6, 8. Very strange. Basically, you see how, hey, stop, look here. See how there's 3 dots on the 10? So how many 10s do you think there are?
30.
3. How many, 25s? How many 25s do you think there are?
Uno.
1. How many 71s do you think there are? A lot. Add them all up. Okay. So that is called a dot plot, and there's the key phrase, dot plot. Okay, next up. Hey, excuse me, sit down. You guys want to stay much later than stop. This is called a histogram. A histogram is a bar graph, don't move, where everything touches each other. From 0 to 5, there were 17. All right? Tomorrow, we break them down into dot plots versus histograms and start including data. Hopefully the technology works properly tomorrow. Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci, smile a lot. Ciao, Zane, adios amigos y amigas, cheerio, galushurus, gadafis, shalom.
It feels weird having 20 pictures of parents in your agenda.
You chose to be. No, it's not.